How did you get 35? Oh, because you would add.
Yeah, because I added 24.
Yeah.
Cool? It didn't go well? Okay, please, don't be shy about asking me. If it's not working for you, you need to ask now, before test time, okay? I'm going to move on. It's on the website if you need it. You can go back and look also. Okay. All right, so elimination. This is another way to find that ordered pair, that point of intersection. I'm a direction follower. I can't help it. Like you get something from IKEA. Do you ever buy anything from IKEA that you got to put together? I like one of those people that like I lay all the parts out and I read the directions. I'm kind of weird like that. What?
Are you a directioner?
I am. Can't help it. Is there another meaning to that I should know? Anyway, I like to write the steps down. So here, take a look. Shh. Okay, this is my turn up here. So Chuck, I need your eyes up here. I need your desk move forward. Come on now. There you go. So this process right here for solving is lining up the same variables from both equations in columns. And you'll see what I'm talking about here in a second. You might need to move the equation around a bit to do this. Circle this. You're going to add down the columns to eliminate one of the variables. Hence the term elimination. We're eliminating a variable. You might need to multiply through by -1 to make this happen. We'll see that as well. Step 3, substitute the value of the variable you found into one of the original equations to find the other variable. All right, I'm going to say this again. To solve the linear system, you need an ordered pair. And you say, yeah, Mrs. Burgess, you keep telling us that. Yeah, but I've been teaching this for years, and people don't give me an ordered pair for an answer. They give me an X and nothing else, or a Y and nothing else. Doesn't work. Okay, so I'm going to write my ordered pair right here. That's what I'm looking for. I need to fill that in. Elimination is a beautiful thing, but I am ready to start. If I add down, I add my columns, will I be able to eliminate one of the variables as the numbers are right now?
Yes.
Which variable can I eliminate if I add? The y's will go away, won't they? Negative 3y plus positive 3y is 0y. So I'm going to cross those out. Then I'm going to draw a line underneath here. I'm going to add the columns down. If I have 4x plus negative 2x, how many x's do I have? The y's are gone. 5 plus negative 7 is what? Okay. Oh, look at how beautiful that is. X equals -1.
Oh my gosh.
I already have my x. I'm going to put that right into my ordered pair. What do I do now? Plug it into either equation. It doesn't matter. I'm going to take this and I'm going to plug it into my first one. Right here. And figure out what y is. Okay, that's a dot. That's not a negative. I accidentally made a dot there, so don't be confused. Okay, so down here I'm going to do 4 times -1 minus 3y equals 5. -4 minus 3y equals 5. It's a little bit longer to get the second variable, but it's still, I think, a little bit easier to do it this way. When you do the math, you get y equals -3. I go through this fast because you should be pretty efficient, like I said yesterday, at this point doing this kind of stuff, solving for one variable. Okay, let's do another one. Put the ordered pair here. That's what I need to fill in. Are they lined up properly? X's over X's and Y's over Y's? Will I eliminate one of them with these numbers as they are? Which one will I eliminate? X. Perfect. Put your line underneath. Add the columns. Down. Add the columns down. Negative 6 plus 2 is negative 4y. 8 plus 4 is 12. Divide. And y equals negative 3. Put that right into my ordered pair. Now I'm going to take and plug it into the second equation just for the heck of it this time. It doesn't matter which one you use. So I'm going to say, okay, 5x plus 2 times negative 3 equals 4. You solve for x right now. Hopefully you get this. Solve for x.
Do you want me to give it to you 6 hours?
Please. Add 6 to both sides. You'd get 5x equals 10 and x equals 2. Do you agree? Isn't it lovely? Yeah, sometimes you still need to know them all. I know. Because when you get into higher level math, you got to know them all, because one will ultimately be better than the other in certain things. So you got to know them all. Okay. I don't think there's really anything particularly special about this one. Is it ready to go? Will we eliminate a variable if we look at the columns? Yeah, so it's really the same thing, so I won't spend time on this one. If you want to know the answer, it's this. Okay? It's really the same thing. Okay, now let's go to this one. Are my x's and y's lined up? Will I eliminate one as they are right now? You may be tempted to say the x's, but they're not opposite signs, so no. If you added, you would have 14x here, and that doesn't work for me. So if you go back here, what did I say right here? You might need to multiply through by a negative 1 to make this happen. So I'm just going to pick one of them. It doesn't matter which one, and multiply everything by negative 1. That way, I can get rid of my x's. So I'm going to rewrite my equations. Negative 7x plus 2y. I'll show you in a second why I'm doing this. And I'm going to keep this one the same.
Wouldn't the 2y become negative 2?
No, it was negative. It was negative, so it went positive. You just change the sign all the way across. So the first one I changed, multiplied everything by negative 1. The second one I kept the same. Now can I eliminate a variable?
Yeah.
Which one? X. Now I can eliminate a variable. Okay, let me set up my ordered pair because I forgot to do that. All right, that's going away. 2y, take away 3y, gives me negative 1y. Negative 5, add 4. And y equals 1. Y equals 1. Okay, let's plug it into, it doesn't matter which one. I'll plug it into the second one again. It doesn't really make too much of a difference. You can plug it into any of them. 7x minus 3 times 1 equals 4. 7x minus 3 equals 4. Add 3 to both sides. And x is going to equal what? 1 again. 1, 1. Okay, so this is multiplying through by negative 1, okay? There's a little trick that we had to do there. We had to multiply through by negative 1. This one here, uh-oh. Houston, we have a problem. What's the problem? They're not lined up.
minus 3x.
It's okay. Shh. Hey, come on. Stay with me. Elise. We need to subtract 3x so that we can line up our variables. So I'm going to keep the first one the same. I really do want the x and y on the same side. I'm going to subtract 3x from both sides, but I'm going to write it first so that the x's are in the same place. Plus 2y equals 6. If you subtract 3x here from both spots, are we all good now? Can we eliminate?
Yeah.
We can. We can eliminate the x's. No. Well, let's see what happens. You'll see what happens. Okay. 6y equals 0. That's okay. Can I still divide by 6? What's 0 divided by 6? Oh, I forgot to put my ordered pair. I'll put it down here. So my y is 0, and that's fine. That's the x-intercept, isn't it? Sure, Mrs. Burgess. It is. So then I'm just going to plug 0 into either equation. It doesn't matter. Yeah.
When you would plug it back in, put 0 back into the equation, if you did the second one, would you still keep it as 2y equals 3x plus 6?
Yep, but then you make the y 0. So 2 times 0 equals 3x plus 6. You can do that one. 0 equals 3x plus 6. What would you do now? You have to subtract 6. Negative 6 equals 3x. So then what does x equal to? Negative 2. Cool? Okay, let's do one more. Because there's a couple things going on here. Here's my ordered pair. All right, they're not lined up, so I got to subtract 4x from both sides. So I'm going to rewrite the first one down here. 2x plus 5y equals 12. That one stayed the same. And I'm going to put the negative 4x first, so it's lined up. This is a positive 5y. It doesn't change. And this is still a positive 6. It doesn't change. Uh-oh. I can't eliminate, so I need to multiply one of them by a negative 1. Doesn't matter. We'll do the first one. And then I'm going to rewrite it just below here as negative 2x minus 5y equals negative 12. So I multiplied this by negative 1 and rewrote it down here. I'm going to cross that one off now. These are the two I'm working with. See what I did? Okay. Am I ready to add down now? Will I eliminate? Yep. This is going to go away. Negative 6x equals negative 6. X is equal to 1. And then we don't need to spend time on the other one. I'll just tell you it turns out to be 2 when you plug it in. You just plug it in, find y. Yeah, yeah? All right, we have to do this fun story problem here. How many people have traveled down the river on a riverboat? Okay. How about back to the floating one? What if you're on a tube? Are you going to go faster if you're going with the current or against the current?
Yes.
Really? Yeah. Obviously you go faster if you have the current pushing you, right?
No.
So let's keep this in mind. A riverboat travels 28 miles upstream against the current in 7 hours. It travels the same distance downstream with the current in 5 hours. It's a lot faster with the current. The speed of the current remains the same. It means that it's not changing at all. during the travel upstream and downstream. Find the average speed of the riverboat in still water and the speed of the current. This is one of my things here, and this is my other, which I wrote right here. Okay, those are my two unknowns. Now, before I jump into writing equations, in order to find the average speed, I need to know the speed that they gave me. So I have to use distance equals rate times time for the upstream and the downstream. I'm going to use this equation right here to find out the rate how long it took them, at what speed to do this. So how long did they travel upstream? 28 miles, right? Upstream, 28 miles, that's my distance. I don't know the rate. And how long did it take them to go upstream? I'm just making it brighter here. 7 hours to go upstream. If I divide both sides by 7, I find out that the rate is 4 miles per hour. Upstream against the current. Downstream, let's see how fast they went downstream. That took them 5 hours. If I divide both sides by 5, I get 5.6 miles per hour. So it's a lot faster when you have the current with you. You say, yeah, okay, so how are we going to use this with our x and our y? So if I'm traveling upstream in the riverboat at a certain pace and I'm fighting the current, is that going to slow me down or is that going to make me go faster?
Oh, yeah.
It's going to slow me down by the speed of the current, isn't it?
Yeah.
So if I'm going at a speed in my riverboat and I'm being slowed down by the current, that equals this 4 miles per hour. Whatever the speed of the riverboat is, take away the speed of the current, caused me to go 4 miles per hour. So now I'm going downstream at my riverboat pace, and I have the current pushing me. So it's going to make me go that much faster. So it's going to be x what? Plus y equals that speed. Oh, would you look at that? We can eliminate. Can't we?
Why?
We can eliminate y.
Why can you eliminate?
Isn't that nifty? I'm going to eliminate y. Be careful. I have x plus x. So how many x's do I have? 2x equals 9.6. Divide by 2. X equals 4.8. Oh, wait a minute. X, what is x? What is x?
Read up the river bud.
X is the speed of the riverboat. So if it was in still water, the riverboat would be going 4.8 miles per hour. If it was in still water. Now I can pick either one of these. I'll just pick the second one here.
This way.
Yeah.
It wouldn't be 4, 8, 8,
Yeah.
That would, because it would be 4.5 and then 6 divided by 2.
Are you with me? Subtract 4.8 and y is equal to 1.2. So the current is 1.2 miles per hour. Isn't that cool? That's like really big boy math right there.